So this proficiency check looked at combining like terms in the first two problems. Then we looked at distributing in the next two. And the bottom three had to do with the area model. So number one, there were two different terms. There were x terms, and there were y terms, and actually there was a third, a number term. If I combine those separately by adding the coefficients, I have 3 minus 4x, or a negative x. If you wanted to write negative 1, you could, but that's for the rookies. For the y terms, we have 4 minus 2, or plus 2. And left for the constants, there's nothing to combine it with, just plus 3. Number 2 may have been intimidating. The trick is to start with the largest exponent and go from there. So I only have a single x cubed term. It's a negative 3. I rewrite it as such. Next up, my squared terms. I have a negative 3 and a positive 6. So 6 minus 3 is a plus 3x squared. I'll just cross these out as I go, actually. So next up, I have x terms. I have a negative 6, a positive 3, a positive 3, a positive 4, a positive 11, and a negative 4. If you're paying attention, the positive 4 and the negative 4 cancel each other out. 3 and 3 make 6, minus 6 cancel each other out. We are left with 11x. Finally, for our constants, we have 5, minus 2, minus 3, again, minus 3 and minus 2, 5, they all cancel out, minus 10 plus 6, leaving us with minus 4. Number 3, when there's a number outside of parentheses like this, that means I'm supposed to multiply it by each term inside of the parentheses. So 5 multiplied by 6x, and 5 multiplied by 2. This top part gives me 30x, and the bottom part gives me 10. It's typically written like this, 30x plus 10. Be wary of negatives. When I distribute negative 4 times negative 2x, I'm multiplying two numbers with the same sign, so it's going to come out as a positive 8x. Whereas negative 4 times a positive 8, different sign, it's going to come out negative. And I typically write this 8x minus 32. For number 5, I'm going to use the area model. So I'm going to take this first quantity, 2x plus 2, and put it here. And then I'm going to take 3x plus 4 and put it here. It doesn't really matter if you had them switched. It still works. I multiply row by column. So this first row, 3x, is multiplied by the first column, 2x. Well, 3 times 2 gives me 6. And then I look at my exponents that are attached to my variables. This x is really x to the first power. And this x is x to the first power. When you multiply variables, you add their exponents. So I end up with x squared, 1 plus 1. Next up, the 4 row and the 2x column, that gives me 8x. The 3x row and the 2 column gives me 6x. And lastly, the 4 row and the 2 column give me 8. I can combine like terms because 8x and 6x are the same term. If I do so, I get 6x squared plus 14x plus 8. The 14 came from 8 plus 6. Number 6 has a similar setup. I can take negative 6x and a positive 1. I'll do it in the different spot this time. And 7x and a positive 8. And then I multiply row by column. This here gives me a negative 42x squared, a 7x, a negative 48x, and an 8. When I combine like terms, my final answer will be negative 42x squared, which came from here, is the only x squared term. When I combine negative 48 plus 7, I got negative 41, and 8 had nothing to be combined with. For number 7, I had a trinomial that is a polynomial with 1, 2, 3 terms, multiplied by a binomial, one with 2 terms. So my setup looked like this. I'm going to take the trinomial, and it has to go on top, 2x squared minus 7x and a 2. And the binomial I'll put here on the left, 5x and minus 3. When I multiply row by column, 5 times 2 gives me 10. And let's add all of the exponents. 2 from x squared, 1 from x, 2 plus 1 gives me 3. This should be 10x cubed. This gives me negative 6x squared. This gives me negative 35x squared because I take 1 plus 1 when I multiply the x's to get 2. This gives me 21x, 10x, and negative 6. When I combine the like terms that are on these diagonals, I end up with negative 41x squared and 31x.